Let's consider the notion of logical equivalence. Here's the definition of equivalence. P, left, right arrow, Q. If you follow down the truth values, you see it's only true when both P is true and Q is true, or when P is false and Q is false. So two propositions are equivalent if they are both true or both false. If this is a tautology, they are said to be logically equivalent. This is almost the universal use case of this concept, so that equivalence almost always means logical equivalence. Here's some examples. On the left, we have the truth table for P and Q. On the right, we have the very similar truth table for Q and P. Both of those logical expressions, P and Q and P, are false unless both P and Q are true, in which case they're both true. So their truth tables are identical, and so they are in every possible world, they have the same truth values, even though P and Q and P are contingent propositions. They're logically equivalent because the by implication of P and Q left, right implies Q and P is a tautology. There are possible worlds in which Calypso the cat wakes up from a nap, and at the same time, the same cat yawns and stretches. That these are possible worlds in which these are both true. In these worlds, these two propositions are contingently equivalent. However, they're not logically equivalent. And this connection is not particularly useful. Here's another example. On the left, we have the truth table for P or not P. You can see that it's always true. Either P is true or not P is true. It's a tautology. On the right, you have P and not P. You can see that it's never the case that both of those are true. So that's a contradiction. Now we can make that contradiction into a tautology with a not, because it will, every time that P and not P is false, it turns that into a true statement. So we have down in the middle of the page, not of P and not P is always true. Now you can notice that the truth tables for the two expressions, the upper left and the middle of the page, have the same truth tables. They're both tautologies, so they're both logically equivalent. This is an example. It's a special case of the fact that all tautologies are logically equivalent to each other. Similarly, all contradictions are logically equivalent to each other. The examples of the first case, in which contingent propositions turn out to be logically equivalent, are the most useful cases. An example is the implication equivalence that we'll consider here. Consider this truth table for not P or Q. It's going to be true whenever either Q is true, that's the first row or the third row, or when not P is true, that's the third row and the fourth row, because not P is true when P is false. You should notice in this truth table, that's the same truth table for implication. It's only false when P is true and Q is false. So this expression is logically equivalent to implication. P implies Q is logically equivalent to not P or Q.